Welcome to a lesson with Dr. Pal. Let's talk about how we can work backwards from geometric sum formula to actually write out a geometric series. For instance, think about this 1 over 1 minus r. This is the result of a geometric series 1 plus r squared plus r cubed plus forever. Because what we do is we look at the first term, which is 1, and then we multiply it by, now if r in absolute value is less than 1, then in the limiting process, in the partial sums, when we look at this fraction, which is uh, if we're um, adding up to degree n minus 1, so we have n terms, then this will be r to the n minus 1 divided by r minus 1. That'll be the partial sum. But in the limiting process, this goes away to 0, multiply top and bottom by negative, and we end up getting 1 over 1 minus r is equal to this sum. So let's practice using that idea. If we have 1 over 1 minus x, we can write this as 1 plus x squared plus x cubed plus x to the fourth, so forth. In other words, a series, x to the n, so it goes from 0 to infinity. A power series. We could rewrite this as a power series in this way. Or if we have like 1 over 1 minus 2x, we could say that this is, quite literally just stick the 2x into this series right here. So like this, and you could even rewrite it as 2 to the n times x to the n, and that's fine. Or what if we had like 1 over 1 plus x? What could you do with that? You could rewrite that as, think of this as 1 over 1 minus negative x, and then just stick negative x into this guy. So negative x to the n, which is the same thing as negative 1 to the n, x to the n, replacing that. So we can, if we have anything like this, we can quickly rewrite it as a power series. Of course, we have to be careful of radius of convergence and interval of convergence when we do so. Let's look at another example here of this. What if we had something like 2 over 3 plus 2x? Does this work? Can we rewrite this? We sure can. We just have to have a 1 here. So we divide top and bottom by 2. Or by 3, sorry. Divide top and bottom by 3. Ivan. Thank you. There we go. So 2x over 3. And then now we can rewrite this. 2/3 times the whole series, because you factor out the 2/3, times the whole series, which is 2x over 3 raised to the n, and starting at 0, going off to infinity. Of course, you could rewrite this as 2/3 times n 0 to infinity, 2 to the n, x to the n over 3 to the n. If we really wanted to, we could distribute this 2/3 to every term and get rid of it there because we distributed it in. So we could have this as our power series. So this is just a little description of how we can take a fraction, which looks a little bit like the result of a geometric sum, and output a power series. Thanks for watching.